All right, this is Math 209, Week 4. Now we're in 10.2. We're reviewing concepts and vocabulary. It's still going to be roots, but now we're going to be using the fraction exponent notation of roots. So the deal is you just have to know how to read this notation, all right? So the idea is, I'm going to scooch over here. When you see 4 raised to the 1/2 power, it means, and this is going to be weird, but you write a 2, you write a root, and you write a 4, and you write the root. Now this 2 right here, always, always, always is that number. And this 1, the numerator, is always, always, always the exponent to the 4. Always. Now in this case, that becomes the second root, or the square root of 4. And if you think about it, this is saying what times itself is equal to 4. And the only option is 2 times 2, or -2 times -2. But when we're simplifying these expressions here, we're always going to just look at the positive value. We don't need to worry about the negative value. So in this case, when you have 2 choices, right? When you have 2 choices, we're always going to do the positive value. So in this case, the answer is 2. Now, let's do the key step is, how do you go from here to here, right? And so let's just kind of do a quick practice. Let's say it's a 5, and it doesn't matter. This is 5 raised to the 3/7 power, all right? What that means is you make a root symbol and you put your 5 in there. Your denominator always, always, always is that number there. And your numerator is always, always, always the exponent inside. It's always that way. So the denominator always goes here. The numerator always goes there. Every single time. And then you can go ahead and continue solving it if you want, but we don't care. I just wanted to show you how you connect the fraction to the root symbol method. All right, so if we wanted to, we need to go over here and say, okay, well, the answer is going to be 2, not -2 or plus or -2. It's just 2, because we're always going to be interested in the positive values. So here, now what does this mean? Well, this means the first thing you do when you have a negative, okay, this is going to be, it's going to feel arbitrary, but it's not. It's the way we do it. And if this was a longer class, I would explain why it makes sense. But, oops, it's -1 over 2. So the first thing you're going to do is you're going to take that and you're going to put it under a 1. So it's going to become 4 raised to the 1/2 power, like that. So it's going to be 1 over 4 raised to the power of 1/2. And you'll notice it goes from a negative to a positive, and that's the whole point. So when you have a negative exponent, you have to move it to the other level. So this was in the numerator, it goes into the denominator. And so now you need to kind of think about this over on scratch papers. This 4 raised to the 1/2 power. Well, we're going to do that over here on scratch paper. 4 raised to the 1/2 power is equal to 2 raised to the second root of 4 raised to the first power. Remember, the 2 goes here, the 1 goes here. Got to simplify this exponent first, so that becomes the second root, becomes the second root of 4, and we know that that answer is 2. All right, so then we can go back over here, and so we now know that this is equal to 2. So that equals 1 over 2. So this is equal to 1/2, and that's why the answer is 1/2. All right, so they want us to kind of take the root symbol and write it as a fraction exponent. And so that's essentially, let's go over here. And so remember, if we had like x raised to the 2/3 power. Okay, what would that mean? That would mean the 3 goes outside the root, and then you have x raised to the 2nd power. It always means that. So in this problem, they want us to go backwards. So they want us to start here and then write it in fractional notation. Well, you got to remember, if you don't see a number there, it's a 2. And if you don't see a number here, it's a 1 as our exponent. And so reverse engineering that, going the other way, you end up with x raised to the 1/2 power. Remember, the 2 goes there, the 1 goes there. So the answer is x raised to the 1/2 power, and so that's why the answer is B. All right, so here they want us to take the a raised to the 1/n power and write it in radical notation. So you know you're going to have that root symbol, and you're going to have the a, and the n goes here, and the 1 goes here. And so that's why the answer is this guy. Okay, so this is, we're going to start here with the root x to the 3rd power. And you need to remember that when you don't have a number there, it's a 2. All right, so, and what is this equal to? Well, the 2 is the denominator of our fraction, and the 3 is our numerator. It's just something you've got to remember. That is your denominator, and this is your numerator. Every single time. It will never ever change. And so the answer is x raised to the 3/2 power. It's just something you have to write down and memorize. All right, so here you've got this 25 raised to the -1/2 power. So we learned that you got to put that under a 1 and make that 25 to the 1/2 power. And then you have to remember that this is 1 over, and then this portion right here you need to remember is to the 2nd root. I shouldn't say 2. I should say the 2nd root of 25 raised to the 1st power. So remember, the 2 becomes the root, and the 1 is the exponent of the 25. And what does that equal? That's 1 over the 2nd root of 25. And remember, we only want the positive values. So this is equal to 1 over 5, 1/5. And so that's why the answer in this case is C, 1/5. So we're basically going back and forth between the exponent notation and the radical notation. So when you have x raised to the 1/5 power, you know you're going to make a root symbol. The x is going to go inside. That denominator is going to go right here. And the numerator is always going to go right here. And that's why the answer is C. All right, so to answer this one, we're going to have to do a little bit of backtracking a little bit. So what we've learned in a previous, I think we learned this in Math 208. If you had m to the 3rd power times m to the 2nd power, that means, you have m times m, that's this part, times n, oops, I didn't want n. I wanted both of these to be m's. So it's going to be times m, that's this part, and that whole thing is equal to m to the 5th power. So what does that mean? Well, basically all you needed to do was add your exponents. All right, 3 plus 2 is 5, and so all you have to do is add your exponents. So remembering that concept, we're going to take this, the square root of x times the 3rd root of x. We're going to change this to x to the 1/2 times This is going to be x to the 1/3. And now we're going to add the 1/2 plus the 1/3. So when you add the 1/2 plus the 1/3, you get 3/6 plus 2/6. That's equal to 5/6. So this is equal to x raised to the 5/6 power. But you'll notice that's none of our choices over here. That's because they want us to change this exponent notation to radical notation. So you got the radical x, and you need to remember that the 6 is outside, the 5 is inside, and that's why the answer is H. So the big deal on this one is remembering that when you are multiplying, now you have to have the same base, and in this case we have x's. When you're multiplying these exponents, you add them, and that's how you get the answer. Isn't that weird? When you multiply, in order to get the answer, you add. Well, that's true, and we know because here's an example of showing it, that when we're multiplying these two exponents, really what you end up doing is adding the exponents.